What's up guys, welcome back. Today we are going to kick off a brand new video series called 5 Days of Decentralization, which is where we look at various decentralization or Internet 3.0 projects and see what they bring to the table, how they compare with one another, and how you can build on them if that's currently possible. And at the end, hopefully you'll be able to decide which projects you want to contribute to in whatever way you want, whether or not it's investment or open source development, marketing, those sorts of things, so you can make the most informed decision possible. So for day one, we're going to kick off by covering a network called MaidSafe, which is a decentralization effort. It's actually not necessarily a cryptocurrency, although they did have an ICO to raise funds back in 2014. But those funds were for the development of the network. Incentives will be paid in an alternative coin called SafeCoin, and you can use those to transact on the Safe network and purchase, utility offerings such as space or compute power, etc. So let's dive into that. All right, so first we're diving into MaidSafe. So we're going to open up Brave browser and we are going to go to MaidSafe.net. And if you're not using Brave, you probably should be. It's a fantastic browser. So yeah, give it a shot if you're not already. But MaidSafe has been in operation and working on this decentralization problem since 2006. Now, of course, 2006 could mean a multitude of things. Either they can't release a product or the problem space is so large and it's gone through multiple iterations. Now, MaidSafe does actually have something you can try out, and that's actually what we're going to take a look at here in this video. But yeah, MaidSafe is based on top of the safenetwork, which is actually a peer-to-peer network rather than a blockchain, but it does have consensus mechanisms built in. Now, safenetwork actually has a different website. Not really sure why, but it does. So if you actually head over to safenetwork.tech, you get this website. And this sort of breaks things down pretty well from a layman's perspective, and of course kind of a technical perspective as well. You've got some technical sections here. For example, highlighting that it's a platform for creating decentralized applications, and they have a fairly good dev hub with some fairly good tutorials. Now, here's the thing though. The primary interface to the Safe network is the Safe browser. They have a browser. So this is yet another browser-based interaction here, which does raise some questions of my own, namely, how are IoT type devices, things outside of the browser going to take advantage of this network? Now, they do have an answer for that. They do actually have some Rust-enabled, Rust is a programming language, Rust-enabled networking frameworks or libraries that can operate with the Safe network. So there are options there, but there is not anything yet really kind of like at the C level where you would tackle things from an operating system perspective. But there could be in the future. The specification and things like that could be, of course, implemented in that language. Now, after you get to safenetwork.tech, you can actually get the Safe browser. Now, of course, this takes you to a GitHub page, so this is probably more for the technically inclined, being that you have to know, well, what operating system you're running, but also which architecture. Now, of course, they really only compile these things for x64, but in the event that you're running something older, you could run into issues. Now, however, they do update this fairly frequently. Now, we have both browsers on our system, and since we're actually on a Mac, it's pretty simple. You just download the zip, and inside it is a standard application. Just drag it into your applications folder. Safe browser has two different browsers, or two different distributions, if you will. First, you see this dev piece here, which actually connects you to the dev network, and you can process transactions or put operations onto the Safe network without incurring an actual cost. But it's not even a testnet, it's a local mock network. So in reality, you're just saving things locally, which actually means that things are not often saved across browser restarts. But that's okay. All right, so you'll see here we have our Safe production browser open. You can sign in to manage your apps, which basically is prompting you for 2 passwords, which are used to create key pairs on the back end and all that wonderful encryption gobbledygook. Now, if you don't have an account, which chances are you won't, you can actually head over to create an account, and the Safe Authenticator window will guide you through how to create an account. Now, the interesting thing about the Safe Network is they've made it a little hard for you to get in. Now, if you continue, you have to have an invitation token to join the network. And how do you get an invitation token? Well, you have to be at least trust level 1 on their network, which means you get forwarded over to the MaidSafe invite page, which is basically where you have to sign in with your Safe Network forum credentials. Now, the thing about that is you have to be at least trust level 1 on the network, which means that you've browsed at least 500 replies, 50 topics, or whatever. So you have to sort of engage with the community before you can actually get in and really start using the Safe Network. And they restrict it by IP address. You have to enter your IP address. So this is not for the layman. This is not for, easy access. Now, do I necessarily disagree with that? No, because their community, as a result, is a heck of a lot less toxic, because really the only people there are the ones who are, really interested in helping test the Safe Network, who are interested in developing applications for the Safe Network. So if you go to the Safe Network forums, you actually see that the conversation is kind of positive, is fairly productive, although it's a little bit more limited than some others because, again, the level of access that's required to use the Safe browser. Now, however, if you're a developer, they don't necessarily have the same forum. If you click developers at the top here, you get forwarded over to safedev.org. So I'm not really sure. Oh, and they don't use the same credentials, by the way. I'm not really sure what their thought process is behind having a different landing page for MaidSafe and then a different landing page for the Safe Network and then forwarding over you to another page to download the browser and then having a separate forum. It's all weird. But all things considered, they're still, shooting, way under par there. So the interesting piece, though, is once you go back to the Safe Network browser and you have your invite codes and all that stuff entered, we're actually just going to go ahead and log in. And it takes a second because it's connecting to the peer-to-peer network on the back end and is authenticating, doing all sorts of great stuff. Okay, so we actually have some authorized applications here. Now, what I can actually do here is I can go ahead and just revoke access to that, and we can reauthorize it so that you see things. But you are always greeted with this page whenever you log in. These are any applications that you've given access to, and the Safe browser is by default there. It treats its own self as an app. Now, the WebID manager is essential because they actually have WebIDs in the browser. Now, oddly enough, the whole thing being experimental, you have to turn on experiments to use it, and then it kind of does its reload piece here. But now you see that you have this really nice drop down here that you can use to manage your WebIDs. Now, if we launch the WebID manager, because I've already got one here, but I can show you what this looks like. It goes to safewebidmgr.dApp, and this loads the WebID manager over the peer-to-peer network. I think that's really cool. Now, however, how does that actually work? Well, in reality, the network is just fetching HTML and JavaScript, and of course, CSS and pretty much front-end attributes. But the browser exposes APIs into JavaScript, which we'll see in a little bit. It exposes APIs that allow you to interact with the Safe Network. And one of the APIs that it exposes is management of WebIDs. So presumably, I guess that's why you have to enable experimental APIs. We can see here, this is one of my other Safe IDs. Once we go to the Safe address, you will notice that this looks familiar. And all of the WebIDs are implemented according to Turtle, or actually, semantic web standards here, this linked data, this LDF stuff that has been really in the spotlight lately thanks to Solid, which is Tim Berners-Lee's project. And that's actually, this integration here is actually what garnered a shout out to MaidSafe from Tim himself. So that's actually, they did a big thing. Oh, Tim is on board with MaidSafe, all this other stuff. Well, it's because they're using linked data, and of course he likes to see that because this creates other interoperability opportunities down the road for using Solid. So if you're actually looking to get a hold of Tim or whatever, maybe you should start integrating some of these technologies if you are in the decentralization space and this is a project that you're working on. Now, let's go to the Safe Authenticator. I've already got a WebID. I'm signed in. It shows up here. So actually, if I go to patter.dApp, it's going to fetch basically a Twitter clone. And this is pretty cool because this is running entirely HTML, JavaScript, CSS in the browser, doing great things. All right, so now if we actually inspect the elements, we can actually see that this is all just running pretty much React code, HTML, CSS, JavaScript, but more importantly, we have quite a bit of code that's here that is essentially the entire application. So you can take a look at what everything is doing. You can actually see that, hey, window.currentWebID, this is something that's actually exposed by the Safe browser. So if I just do window.currentWebID, it's undefined. Now, why is it undefined? Well, if I go back to my window here in just a second, and I will change this for you. If I go back to my window here and I say, select my WebID, which is this, you will notice that it actually refreshes itself. Now, if we go back to our JavaScript console, all right, so now if we have our developer tools back up, now that we've got our WebID selected, and we try window.currentWebID again, we see that we actually in JavaScript have access to all of that wonderful linked data in JSON form. So it's like JSON LD is actually the format. Now, this is really, really useful considering now you can just use front-end web technologies to develop dApps. You don't have to learn Solidity or anything like that. All of this stuff is just supported by the browser because the browser is the one exposing a lot of those custom APIs. So now, if we just go back to our browser here, you can see that since we have our WebID selected, we're seeing all of our hello world stuff, and if we want to post something, we're just going to click ID me here, and we will see that, hey, you are requesting authorization. This application is made by MaidSafe.net Limited. Do you want to give this application access to your WebID information? So this is actually the browser posting this up to me saying, hey, look, it's sort of like an OAuth thing. So I'll go ahead and click accept. And as soon as I click accept, the Safe Network is going to effectively allow this dApp to access my credentials or my public profile information. And effectively, we should see these things come online. And yes, we did. So now these text fields here, summary and something super important, which is interesting because you have kind of like a subject, and MaidSafe is cool, you know, and post that there. And again, you know, it will eventually post here to the network. And this was something that I did earlier. This was something I did on the 26th of December. So that is like the first dApp that Safe has kind of released that's really allows you to play around. They've got a bunch of other dApps that we can explore, that you can explore. So download the browser, give it a shot. Now, what does it look like to develop on MaidSafe? So let's kind of take a look at that. But in order to do that, we're going to have to download the dev browser, install that, and sort of you know, get that up and running, because that will allow us to process transactions locally using a mock network. All right, so we've got our mock browser up and going. You can tell because we've got a big mock network sort of badge there. Now the thing is when you're doing development on the mock network, all of this takes place completely locally, so you're actually not connected to the peer mesh at all. Now, you do have an account secret and an account password. If I just kind of make up whatever, log in, it'll say account does not exist. But what we can do is we can create an account, we can continue, we can claim an invitation, but actually You just kind of enter whatever invitation token you want. You click next, you set an account secret and an account password. Okay, so now we've got our default pop-up that the safe browser request authorization. We can go ahead and click accept there, and now we kind of see the same stuff that we're seeing in the production browser. Now, the one thing that I did not point out, and I apologize, is actually this account status badge up in the corner. This actually is the number of store and modify operations that this account has actually performed, because the safe network charges you for the number of store, so basically create and update operations, because it costs those peers money to store that data, and that payment is how they incentivize them. The store and modify operations are basically like this big key value store, so it's like a dictionary of sorts, but you can store all sorts of arbitrary data in it. Really, most of it's JSON. Now, or linked to data. So what we can actually do is create an application that we can access on our local platform in this browser, and we can make sure that it's taking advantage of the APIs. Now, the thing that most web applications are going to need is that WebID piece. Similar to other projects in the space like Neo or whatever, or specifically NOS, is the fact that they do have WebIDs integrated into the browser. Now, if we toggle experiments and we try to go, so if we log back in again, this is just, they kind of need to work on their UX, which again, I'll cover this at the end of the video. So we log in, and we're back where we started. Now, if I try to hit this drop down, it'll say no web IDs found. We'll launch our WebID manager, and then nothing. Why? Because for whatever reason, in the dev browser, you got to download something else in order to have access to the WebID manager, despite the fact that in the production browser, it comes out of the box. It's kind of not intuitive, but the community was insanely helpful when I was asking this question. All right, so in order to solve this WebID management in the mock browser problem that we're having, we go to the MaidSafe GitHub and we search for WebID, and of course it's not there. It's safe WebID manager, and I believe this is actually what we need in order to make our local application actually manage the WebIDs. So what we're going to do here is we're going to copy our Git repo URL. We're going to do the standard thing of wget, or what? No, git clone, and paste the URL. Let's see what happens. All right, so npm I for npm install. This is going to install all of our dependencies. Standard npm node project. All right, so now it's done, and we will just do npm start and see what happens. Cool, server running at localhost 1234. Okay, now it's gonna load. Cool. All right, so now we get the standard, again, kind of OAuth, hey, I need authorization of your data, prompt, and you can actually view the details, and the details, wow, the details will actually tell you specifically which containers of data that this is actually going to access and what access it needs. So this actually is asking for full access to the WebID manager, which is our kind of our own application, but the public names and the public containers that are carried around from site to site. So we will go ahead and accept that. And now all looks good. So we don't have any current WebIDs. Let's go ahead and create one. And we're going to submit, and guess what? Since it is storing locally, it was created immediately. Now, the one downside, well, one of the downsides to MaidSafe, and particularly the Safe browser, is every single time that they update versions of the browser, depending on what version you're running, they could potentially break websites that are already out there, or, well, the dApps that are already out there, considering that the dApps are utilizing browser-based APIs that are, again, native to the software. So we do see the WebID manager is there now, so everything looks good. We should be able to hit the drop down here, and yep, we do have our WebIDs. This was fetched from our mock network saying, hey, based on the account that is currently logged into this browser, because now if we were in production, if I log into any other browser, I should be able to see my WebIDs right there in the browser. So now we see that there. So now we can actually build our own application that is going to take advantage of this WebID and of course the safe network. Okay, so in order for us to get started, we're going to develop a web application on the safe network. Now, safe network allows you to use a plethora of technologies, or JavaScript frameworks at least, to develop your applications. But the main two paths that you can use to develop a safe network application are raw Node.js or Electron, or of course a web application that runs inside of the safe browser. So for something like a desktop application, or the safe browser itself actually, could be used, they could actually use the Node.js APIs. We will do a web application considering we've just got the browser and all the WebID stuff kind of set up for our mock network. They do provide some boilerplate, so if we actually clone this Git repository, we should be able to, of course, find something. So we can actually just do a git clone into safe examples and cd safe examples, and you will actually see that they have a number of templates for you, or boilerplates, and we are going to use the safe web app quick start. So if we actually do a cd, and we'll kind of put this next to each other here so we can just sort of follow along. So cd safe web app quick start. We can actually do an npm install, and no telling how long this will take again because it's npm, but let it churn through that for a second. All right, so npm completed successfully, and now we can do an npm start, and that should go ahead and spin up our npm application. Cool. Okay, so we are running on localhost 5000, so if we actually open up our safe browser, we will actually see this page here, which is an absurdly simple page, but in reality what this is going to demonstrate are basic CRUD, create, read, update, delete options or operations on the safe network. So what we can actually do is open up the repository in Visual Studio Code, and our safe examples, safe web app quick start, and this is of course the baseline code. So it is a simple view application. We've got some stuff that's stubbed out here, so actually all the view type stuff is done for us. What we actually have to fill in here are our safe network operations. And again, you have the authorization scheme, which is basically where it prompts you for access. Then you can create, you can read, you can insert new items, you know, basically things like that. But this create mutable data is going to sort of set up our baseline data structure. These are going to manipulate it. So let's go ahead and get our tutorial back on screen here, and things look good. So basically what we need to do though is first we need to authorize the safe network to utilize this application, or at least authorize this application access to the network. So let's go ahead and take a look at what's going on here, and we can sort of break this down. So we will copy this code here, and we will effectively be replacing our authorize and connect routine. So the name of the application is very important, so we can actually say hello safe network. This ID is a lot like a Java class identifier or a namespace. This actually will uniquely identify the network, the application when we distribute it using, you know, third-party app directories and things like that. It's also used for internal data keeping, version 1.0.0, and of course we can just say, you know, I don't know, Jimmy Tech or something like that. Then we actually dispatch to the browser window.safe.initializeApp with this, and this is actually what creates that authorization header. We'll log some info there, but then once we get authorization, we will effectively get a URI that uniquely allocates browser resources and identifies this application to the browser, or this instance of the application to the browser. And then of course we authorize everything there, which essentially will open up all of the safe network APIs to our application. And then of course we log in, and this causes our application, once we're fully logged in, to appear in that authorized web applications pane when we first open the browser, and of course we'll expose our personal identification or personal storage access to this application, depending on which permissions it needed. Now, so let's go ahead and save that. And if we go back to our safe browser, you can see it actually auto reloads. So as soon as we made a modification, it went ahead and refreshed. So it says, hey, this application is requesting authentication and Jimmy Tech. So we indeed did get that. Now, if we open up this element in our inspector, okay, so we actually see in our console authorizing safe application, which in our console.log is there. So we verify that this code is indeed running. Let's go ahead and put that aside for a second, and we will go ahead and accept this piece. And we should be able to get that going. So now you can actually see our Hello Safe Network is there in the bottom. And once we go back to our developer tools, safe application authorized by user, application connected to the network. And again, that's because we are awaiting here. So now we are online, we have access to the safe network, everything's looking good. Let's see what is next. Now, so next we have to create a public mutable data. Now, mutable data meaning that we can actually change this. So for example, when we are looking at posts and things like that, these are mutable data. When we're looking at a profile, it's mutable data. We can actually go through and update it. Immutable data is stored vastly differently. So what we can actually do here is we take these type tags and let's kind of break this piece down. So we will override our create mutable data function here, which is again just sort of a boilerplate template. Okay, so in our create mutable data, we choose a random type tag. This could be really anything, but there is a reserved range on the lower end of these type tags. And these effectively identify uniquely what type of data it is. So when you fetch, you say, hey, I'm only interested in data of this type. It allows you to segment out your data operations, which is fantastic. We will then request our browser API create a new random public key, or at least a bucket for this mutable data. And this initial data is really just a JSON blob. So what we will actually store is kind of a dictionary of values. So we can say ABC123 and DEF 456. But you'll notice that these are actually JSON strings because, again, we're just storing arbitrary data here. But what is, in essence, a pretty strict structure is the fact that you have to have it keyed off of these IDs. So this could really be anything we want. We can actually go ahead and just sort of keep that where, kind of leave it as it is. But essentially, since this is a trip list application, we can do kind of some text and MAID and all that sort of stuff. We can kind of check them off, and we could essentially be editing that mutable data. And then we call md.quickSetup initial data. So in essence, what this is going to do is this is going to create the mutable data structure for us on the network and is going to allow us write access to update this. So using this public key that we created, we're going to take this data and basically go ahead and shove it into the network, and we're going to save it, in essence, into this MD variable so that our other functions can access it. Now, let's go ahead, save that, everything looks good, and we can do our Beaker browser, or sorry, not Beaker browser, but go back to our safe browser, and we can see that our stuff should be there. Okay, so once we go back to our browser here, we see that it's trying to authorize our application again, and if we inspect our elements here, we should see that creating mutable data with initial data set, that's perfect. So now that mutable data should actually already be on the network. So if we go back to our tutorial, now we have to read these mutable data entries. So we've created the structure here, and we can actually go ahead and kind of replace the getItems function, which is going to essentially retrieve this mutable data and bind it into the interface. So let's go ahead and do that, because this should be the time where we see some good stuff happen. So this should return an array of items off of the network. But let's kind of break this down. So we have our md.getEntries, and this is effectively going to say, hey, give me all the mutable data that you have for this data type. We are going to essentially break that JSON data structure down, and then we're going to loop through that JSON data structure, so these guys. So this entries list is pretty much what's in here. And we are going to look at the entry value, but we also have entry.key, which again is these unique IDs. These have to be unique. So these are sort of our local database identifiers. Think about it like an auto increment in MySQL, except you're generating the keys yourself. So we should actually be able to save this. Our web application should refresh. We should be able to accept. And voila, we now have our mutable data showing up in our interface, completely driven by peer-to-peer. This is amazing. Oh my gosh, all the possibilities. Now, if we scroll down, now we need to be able to sort of create these mutable data entries and modify, in essence, our overall data structure. So let's go ahead and copy the insert item and paste it in, and let's sort of break that down. Okay, so insert item basically takes a key and a value. So the key in this case is basically just going to be passed in verbatim as well as the value into the function. And in our app view, we can see that the key is actually just generated by a math random function. And really this is just for use for the UI. It's sort of like adding the ID equals HTML attribute to things. But we can insert the item there. We can essentially blank out the trip text, which is going to blank out the text in the UI, and then we call, hey, safenetwork, insert this item here, which is going to effectively call this. We're going to say, hey, this is a new mutation on our already existing mutable data, and then we apply it, and then the network just sort of does what it does and stores that JSON blob into the mutable data. Then we call refresh list, which is going to then call get items, which we implemented in the last step. So it goes through that cycle again, saying, hey, after we've applied this data onto the network, fetch it again for me so we can update our user interface. So let's go ahead and save that. Okay, so we have our application. So now we should be able to add something to this list. We've gone ahead and authorized it. We're going to hit test. And unfortunately, we get an error. It said value argument must not be a number. So let's take a look at our code and figure out what's going on. So our code basically has a random key that we're generating. We store random keys as pretty much a number between 1 and 10,000. However, something has changed, and thus this tutorial is wrong. So what we actually have to do is we need to change the random key to a string, which effectively now what we're doing is we're generating a very large random number that's basically 32 bits in length, or whatnot. Then we effectively change it to a string, slice some stuff off. I stole this from Stack Overflow. But basically, I just want to generate a random string of 32 length. So what we're going to do there is we're going to set that to our random key, and we're going to save it and see if that changes our outcome. Because again, that's the only thing that is a number. And I have a feeling that given the stack trace, which is actually in this buffer parser here, they need something that is not a number. So if we go back to our application now, it should have refreshed, and it did. Let's go ahead and accept this. Let's go try to add Fora to our trip, and there we go. It went ahead and added it. Everything looks hunky-dory, and it looks pretty good. So now let's go ahead and move on to the next point in our tutorial, which is going to be, and by the way, credit where credit's due. Thank you very much, Widows, for the answer. Cool. So if we go back to our Dev Hub, we're going to just go ahead and move on to updating and removing entries. And let's go ahead and copy that and break it down. So go back to our code and go back to safenetwork.js. Update item, delete items, remove our template. Okay, so update items effectively are going to apply another mutation, but not necessarily the same as the insert. This actually applies the update We give it the key, which is again that big string that we create there, and the JSON stringify value, and then version +1, because again, all of the data is versioned. We could actually easily revert back to another version of the data if we wanted to. So it's sort of like an append-only log. It's pretty slick for a distributed data structure. Delete items, we basically do the same thing. We get effectively an array because we can multi-select. We get a new mutation ready. We loop through all of the arrays of items that we specified, and then we apply a delete mutation and increment the version number. Then we apply that change to the log. And then again, our application logic after those is effectively going to refresh the list again. Anytime that we modify the data structure, we refresh the list because that allows the UI to update. So if we save that stuff, we should go back to the safe browser, get another accept. We say Bora Bora again. We got our nice trip there. We say check it off. And then we could actually hit this button here to say remove trips already made. So anything that we have selected, it says remove those items. Now again, being that this is a test application, if we refresh and accept, it's basically going to wipe out the data every single time. But this stuff is working on the decentralized safe network, or it should, provided the APIs are the same when we move from the mock network browser over to our production browser. So that's actually how easy it is to create a distributed application on the safe network. It's just utilizing JavaScript. In this case, beautifully, we were able to use Vue. We did not have to learn Solidity or any of those other, smart contract type languages, because this stuff is using basic web technologies. It's utilizing, however, APIs that are enabled by the browser. So what's my review overall of the MaidSafe network? Well, unfortunately, the MaidSafe network used to be based, well, actually, fortunately, back then, it was based on the Beaker browser. And the Beaker browser is something that we'll cover later on, but the Beaker browser is a decentralized web browser without the blockchain component. So it doesn't have all the incentives, right? It's missing the currency aspect of it. It is fully distributed though, but it does give customers access to the ClearNet, which is the internet that we all know and love kind of today. But basically, this browser is programmed to not give anyone access to ClearNet. So if we actually tried to go to Google, it would not work. So it would say no content found at requested address. Why? Because it basically did a hash table lookup of this and then effectively said, hey, there's no key found. This is going to be really difficult for consumers. Consumers aren't going to really just kind of hightail it off to a new browser that's not going to give them access. The other thing is that the user experience in this is really clunky. For example, whenever I try to inspect elements, and I close the window or I minimize the window and do inspect element, I never see it again. And if I right click the browser in my taskbar, I can't find the damn, I can't find the browser anymore, or I can't find the inspector. So there's a lot of weird UX stuff. You can't reorder tabs into multiple windows. Like it's very clunky, but it's also very early. But I asked, like, sort of, hey, why is this, what was the, consensus behind this? And really I got kind of two answers. One was the guy that made the browser just sort of wanted to see if he could do a browser. And the second piece was the fact that they didn't want any of the security risks on ClearNet. So they said, hey, we want to jail everybody away from that and make sure that the applications stay secure so you can only communicate with safe network resources. Now, I don't disagree with that, but unfortunately, there's not really any intermediate crossover right now. And I would have preferred to have seen something maybe like an add-on to the Brave browser, or at least just opening up ClearNet access optionally in the browser so that people could continue to use this and doing the business that they're usually doing, but also consume applications, sort of, dApps on a kind of case-by-case basis. And that's what Beaker browser allows you to do. This used to be based on Beaker Browser, but a while ago they kind of took a turn and said, hey, no, we're going to base this on Peruse, which is kind of what you see here. I think MaidSafe is definitely leaps and bounds ahead of a lot of other projects. Their developer onboarding material is great. The community is fantastic. You've got some great people there that are doing some great things. I would like to see some of these things tweaked though. Obviously they need to go through and update some of their tutorial material, which is always difficult. So I definitely like to see them do that. But ultimately I give it, hey, 3 out of 5 stars for sure. I'd like to see them ship something though, really something for consumers. If they've been doing this since 2006, I'd really like to see some consumer product out there, or at least consumer grade product, and abstract away all the crypto gunk, if you need to, but that's sort of the downside there. But they're definitely headed in the right direction. I love the WebID integration. I love the ease of use with regards to managing JavaScript, content and sort of deploying dApps. So again, that's what I think about this. That's about all the time we have here today. If you like what you saw in this episode, please hit that like and subscribe button, and feel free to comment below with any questions about this project or future projects you'd like to see on this show. Thanks again, and I'll see you next time.